let's get right to it. Let me just make sure this is recording, and it is. All right, first question. Sarah wants to make fruit baskets. It's a GCF question. Goes back to early. She has 32 oranges and 20 baskets, and then now we know each basket is going to have the same number of oranges and the same number of apples. What is the greatest number of baskets that she can make? So, let's do it this way. So, it's a GCF problem because obviously we have the word greatest number. So you have baskets. One basket, two baskets. Here you're going to have oranges and apples. And on this one, you're going to also have oranges and apples. I don't know how many yet, but if I have 3 oranges here and 4 apples, I'm going to have 3 oranges here and 4 apples. And same for every other basket that I make. All right, so that's the idea. So let's find out how many baskets you can make. So let's use the ladder method. 32, 20. Let's pick a number. I can use 4. 432 8 times. 425 times. Can I go on? No, I can't. So in this case, this represents the greatest numbers of class. So my GCF is 4, and GCF is the greatest the greatest number of baskets I can make. Well, I can make. Let's just see if that works. 1 basket, 2 baskets, 3 baskets, 4 baskets. I'm going to write 32 as oranges, so let me write oranges here. 20 was apples. So I get 8 and 5, 8 and 5, 8 and 5, and 8 and 5. So 8 oranges, 16 oranges, plus another 8, 24, plus another 8, 32. Check. Apples, 5, 10, 15, 20, total of 20. So good. I can make a total of 4 baskets, each one having 8 oranges and 5 apples. Okay. Next one. Sam plays basketball every 8 days and plays soccer every 12 days. How often does she play both sports on the same day? Okay, so it's something that's repeating over and over with something else that's repeating over and over. When will they meet down the line? Well, it's an LCM. Okay, so LCM, let's see, pick 4 again. That 4 goes into 8 2 times, 4 going to 12 3 times. Remember, LCM, you sort of form an L. You multiply 4 times 2 times 3, and LCM is 4 times 2 times 3. 4 times 2 is 8, and 3 is 24. So in 24 days, they would make. So if you actually, let's do it the other way to it by listening. So you got 8. This is basketball, and then soccer would be 12. So on the 8th, on the 8th, and then on the 16th, and the 24th, 12, and then on the 24th. On the 24th day, notice that she's going to play both sports on the same day. So the answer here, how often does she play both sports on the same day? Every 24 days. Okay. Okay, here we go. Let's see if I can load the screen. Tina says the prime factorization of 80 is 2 times 2 times 4 times 5. Is she correct? I have no idea. Well, let's do this. Remember prime factorization? All right, let's break it up. 80, I'll pick 8 and 10. 8 will be 2 and 4. I will circle the 2. And then I'll break the 4 into 2 and 2, and I'll circle both of them because they're prime numbers. 10, I'll make it into 2 and 5, and I can circle both because they're both prime numbers. So 80, another way of writing 80 would be 2 times 2 times 2 times 2. So that's 2, 4 times 1, 2, 3, 4, and times the 5 at the end. So we can tell that Tina's not correct because this was good, but she forgot to break that 4 down. So she's not correct because the prime factorization would be 2 times 2 times 2 times 2 times 5, or better yet, 2 to the 4th times 5. Remember, prime factorization means that all the factors here should be prime numbers, and hers, because of this 4 is a composite, it wasn't. Okay. Thomas says that 3/4 is the same thing as 3 times 4, which results in 12. Do I agree or do I agree? No, I don't. Okay. A lot of you have done this. You multiply the base and the power, and that's not what it means. 3 to the 4th means that the base number, 3, is multiplied by itself 4 times. So that equals to actually 3 times 3 times 3 times 3, which is definitely not 12. Well, these two 3 multiplied is 9. 9 times that 3 will give you 27, and then 27 times the last 3 results in 81. Okay, so 3 to the 4th is definitely not 3 times 5. It's actually 3 multiplied by itself 4 times, which gives us 81. Okay, so this will be our first spiraled, I guess, homework, where we actually do homework that includes topics from things we did in the past. Okay, this way everything keeps fresh throughout the year. Use the street property, Angry Birds. So remember, 4 attacks 5, and then 4 attacks the 8. So let's write the expression out. It'll be 4 times 5. Remember, we use a dot. Plus, that 4 is going to attack the 8 again. 4 times 8. Okay, so just to 4 times 5 here is 20. 4 times 8 is 32. So there's an expression that we could create. This and this have the same meaning. Okay, if you continue, you'll definitely get 52 at the bottom. That's okay. So to create an equivalent expression, this is a different expression. 20 plus 32 is the same thing as 4 parentheses 5 plus 8. Okay, I just created an expression that's equivalent. Now this one, remember when we did it in class? We want to find out, we want to go backwards. Okay, we have to factor out. So think of a number, all the possibilities. Okay, what number outside can be multiplied by these two numbers inside to give us this? So we're almost going backwards. So if you remember, you can use the ladder method. It comes in very handy for this. Here's your 28, here's 42. Let's say pick 4. 4 goes 28 7 times. 4 goes to 12. Does it go in 12? No, it doesn't. 42, no, it doesn't. So sorry. Let's go back. Let's try 2. 2 goes to 14. 2 goes into 42 21 times. And then I can do 7. 7 goes 14 2 times. 7 goes to 21 3 times. So this is a, notice that, we want to take out the biggest number. So this is a GCF. We're going to use the GCF. And that is going to put 14 over here. 2 times 7 is 14. And then these numbers fall nicely in place here. 2 and the 3 goes here. You can always check. If I multiply 14 times 2, does it give me 28? Yes, it does. Plus, attack the 14 times 3, does it give me 42? Yes, it does. So 14 times 14 parentheses 2 plus 3 is the same thing as 28 plus 42. I did that backwards, okay? That's that. So let's move on. Sam wants to give 7/8 of her cake to her 3 friends. What equal share of the cake will each of the friends receive? Well, let's model this. You can do it both ways. Solve in 2 ways, it says. 1, 4, 4, cut it again, cut it again, cut it again, cut it again. So if you're going to show it, so 7/8, something like this. Okay. 7/8 of a cake. I want to cut, and 3 friends want to share it as well. 3 doesn't go to 7 evenly, so let me cut this in 3 parts. So the top layer over here, I'm going to cut this line. That whole row to the top goes for friend A. Let's call that A, and A. The middle one, I'm going to cut that again, cut across. That's going to go to friend B. And the last row here goes to friend C. So you'll notice that every friend gets an equal amount. So friend A, or B, or C, they each will get, let's see, 1, 2, 3, 4, 5, 6, 7. 7 out of how many total? Well, there's 1, 2, 3 going up, and then 1, 2, 3, 4, 5, 6, 7, 8, 24. Remember, you have to count these white ones too, okay? So each friend gets 7 out of 24. Another way of solving this would be to set it up, and you have 7/8 divided by 3, and some of you like to do 3 divided by 7/8, but it's not. You're not cutting the friends, you're cutting the cake. Find the LCM. Let's put the 3 over 1. LCM is 8 times 8 times 8, and you get 24. Now our denominators are the same. I can cross this out and write it as a fraction, 7/24. Notice we get the same exact answer. Okay, Taylor worked $80. Taylor earned $80.75 last week after working for 8.5 hours. How much does she earn per hour? Well, if she's the total that she made, this is the total number of hours that she worked. Well, let's find out how much she worked or made in 1 hour. Division problem. 80.75. I'm going to divide it by the number of hours she worked. 8.5. I'm going to move this over. Becomes 85. So let me just make it over here. I moved it once, or times 10, and I'm going to move it over here, or times 10 again. The same thing. And that allows me to make that into 807.5. Okay, so our new problem ends up being this. Let's move the decimal up top. 85 does not go into 8, nor in 80, but goes into 7. I'm going to say 9 times. No idea what that is. 9 times 5 is 45. Carry the 4. 9 times 8 is 72, plus 4 is 76. 7 minus 5 is 2. Borrow. 10 minus 6 is 4. 5, bring it down. Now 85 goes to 425. I don't know, 5 times? Does it? Yep, it does actually. Perfectly. 5 times 5, 25. Carry the 2, 42. So her hourly rate, she makes $9.50 an hour. Okay. Make this up. Oh, Kim bought $1 bag of chips for $1.49. Box of cookies and a large coffee. She paid with a $20 bill. What was her change? Well, let's add it up. So it's $1.49 for the chips. Decimal and the decimal. This is the box of cookies. And a cup of coffee for $2.49. My decimals are lined up because this is an addition problem right now. Let me add a 0 as a placeholder. 18 goes 1, 17 goes 1 again. 3, 4, 5, 6, 7. Her total was $7.78. So subtracted by $20 from $20. Line up your decimals again. 7, 7, 8. Let's see how much change you get. You're going to borrow from a 2. That becomes a 10, which becomes a 9. This becomes a 10, which becomes a 9. And this becomes a 10. Minus 8 is 2. 2. 9 minus 7 is 1. And then 1 comes down. Her change is 11.22 cents. Determine what sets each of the following numbers belong to. Well, rational does not belong to the counting. Okay, remember the counting starts at 1, but it belongs to the whole numbers. It belongs to the integers. And it's rational. Okay, so we don't have to write decimal and fractions. Let's just keep decimal and fractions in the rational. Okay, so negative 23, it's not a counting number. It's not a whole number, but it's definitely in the integer family. And it's rational. Okay, which would make it, which means it could also be a decimal and a fraction. A fraction if we put it over 1, and a decimal if we add a dot and a 0. So that makes it rational. And it's rational because it's also an integer. Negative 1.33, it's not a counting number. It's not a whole number. It's definitely not an integer. Okay, just because it's negative doesn't make it an integer. Okay, but it's a decimal, so that makes it a rational. Okay, easy. Place the following numbers on the number line below. Okay, feeling this one's gonna be hard. So let's see. Make that a 0. Make that a 1. Make that a 2. Make that a 3. I don't think I need anything higher than that. Negative 1. Negative 2. Negative 3. I'm going to make an arrow on this side and an arrow on that side, indicating my number line grows infinity both ways. So let's start with 2.4. 2.4, it's, so think of dollars, I guess. $2 here. $2.40 that says, so it's a little bit less than half. 2.4 right there. Negative 0.04. Well, think about where the positive, that says 4 cents. 4 cents would be right here. Its opposite, which is negative 4 cents, should be exactly on the same side, very close to 0. So there's my negative 0.4. So that's one way of using opposites. Okay, you can always use it to locate its, if you have trouble locating its negative, locate its positive first, and then just see where it's not. It's negative. So it's negative 1 2/3. Negative 1 2/3. Okay. So here's negative 1. Now break that in thirds, right? So that break the next. So this is negative 1 1/3. Negative 1 2/3 would be right here. Remember, we're going that way. Okay. Negative 1 2/3, which is also the same thing as negative 1.666. That goes on forever. Negative 1.5. Well, negative 1.5 should be between negative 1 and negative 2 and exactly in the middle. So let me just change colors with that one. It should be right here in the middle. Negative 1.5. 1.3. Again, this is 0. $1. 1.3 to $1.30. So about here. 3. Negative 2.1. Okay, negative 2.1 is, this is 0, negative $1, negative $2, and negative 2.1 should be about here. Negative 2.1. And finally, 40 cents, but on the negative. 40 cents positive will be here. 40 cents negative should be on that same side, just a little bit less than half. Negative 0.4. Okay. All right, so we're going to be doing this at least 3 times a week. Okay, the spiral. And that's about it. Let me shut this off now.